Ideal gas law. Volume, pressure and temperature prescribe the state of gas. Here in state 1, gas has one state, and here in state 2, it has another state. So how can I prescribe these conditions with pressure, volume and temperature? Let's take a look of ideal gas law. Ideal gas law is equation that prescribes the state of gas. The basic assumption is that gas behaves like ideal gas. We can conduct the ideal gas law from pressure law and Boyle's law. Because ideal gas law doesn't depend on processes, we can think that there is first an isochoric process and then an isothermal process. Let's note the volume between processes with V. We can solve the V from pressure law by multiplying the equation with T1. Then we insert the V to Boyle's law, and we get P1 B1 is P2 times V2 T1 over T2. And let's divide this formula with T1 and we get PV over T is constant. This constant C is known. It is NR, where N is amount of substance in moles and R is gas constant. We can write this law PV over T is NR, or we can multiply this equation with T and get PV is nRT. You can see the units here. Notice that unit of pressure is in bars. We can look this gas law from another point of view. We can solve all gas laws from it. In isothermal process, T is constant. If we multiply with T this ideal gas law, we get PV is CT. Both of the C and T are constant, so we get PV is constant, which is law of isothermal process. In similar manner, you can solve the isobaric and isochoric processes. We can conclude that only equation that you need with gases is ideal gas law.